Hi guys, so for this video we're going to be looking at differentiation by first principle. This is an area that a lot of students find difficult to understand, so I thought I'd do a video on it. So all differentiation by first principle is basically average rate of change, just with a little extra tricks to it. So first we're going to look at this curve. So we've got a point A. And then let's say we've got a point B. And now finding the rate of change between these points should be something we're all familiar with. It's just finding the gradient of a linear line. So if we draw a line between A and B, we should know that the gradient's just going to be rise over run. So if this curve is f of x, our gradient of that curve is going to be equal to the rise, which is going to be y2 minus y1, so f of b minus f of a over the run, which is going to be b minus a. So that is going to be the average rate of change. So let's talk about now finding instantaneous rate of change. What happens if we want to find the rate of change that's going on at the point A, not between A and another point, but at A? Well, what we can do is we can try and see how we can get a better estimation. So let's say we moved point B. Point B is now closer to A. And so if we now draw another line between A and B, we should be able to see that the gradient of this new line is closer to the gradient that's going to be at A. So the gradient at A is going to be this line. So our new line between A and B is closer than what it was before. Before we had a line from this point. So we should all be able to identify that as B gets closer to A, we can see that the gradient at point A becomes closer and closer. The margin for error decreases. So this distance between A and B, let's call it h. Okay, and so instead of using A, let's use x, because that's what we use in maths. And so we want to find the derivative at point x, our instantaneous rate of change. So point B is just x plus h now. And so our gradient for this line is now going to be our rise, so f of x plus h minus f of x, over the run, which is x plus h minus x. So the same as before, we've just subbed in our value x plus h for b and x for a. Okay, now what we found earlier was that as we decrease the value of h, as our 2 points get closer and closer together, the instantaneous rate of change becomes more exact. The accuracy of it increases. So what we use is something in maths called a limit. And so we say the limit as h approaches 0, okay, of our average rate of change. So this is how we get our differentiation by first principle. dy dx, or f of f dash of x, is going to be equal to the limit as h approaches 0 of f of x plus h minus f of x over x plus h minus x, which we can simplify to being just h. So that is differentiation by first principle. It is not as difficult as a lot of people find it to be. All it is average rate of change between 2 points, and we just basically make h approach 0. So that's something that a lot of students find hard to work with, but it shouldn't be. It should be just as simple as finding average rate of change. Thank you.